Properties of logs. If you take a look at the things that are on the screen, they're the things that you kind of have to memorize unless you're just used to working with them, and often in which case you will have memorized them just from working with them. And what they say is that when you are multiplying inside of an argument, if you take a look at what's going on in here, the multiplication is taking place inside of an argument, then we can split it up into separate logs, and those separate logs will be added together. If we're dividing inside an argument, we can split it up into separate logs, and then we will be subtracting the separate logs. Lastly, if we are raising to a power inside of an argument, then that exponent comes down in front of the word log and becomes a coefficient or multiplier. So the question is, what's happening inside of the argument? If you happen to see an argument, I just want to make a point on this last one here. If you happen to see an argument written this way, there's no difference between that and what you see here. So it's all about when you have multiple things going on inside of the argument of one log, we can expand that into multiple logs. We can also go the other direction. If you start off with something that has multiple logs, you can contract it into a single log. And if you have to contract it into a single log, then you're going to have more things going on inside of those arguments. Notice that inside of these arguments here, there's really only one thing happening, one variable or perhaps one number. So let's see how we apply this in practice. If I have to expand a log, the first thing I'll do is figure out how many word logs I need to write. I'm going to rewrite that word log. I have an X, I have a Y, and I have an N. So I'm going to write a word log for each one of those. Word for the log X, word for the log Y, word for the word for log N. And now I'm going to put those variables inside the arguments. Put the X here. We'll put the Y here. Put the N there. And then I'm going to ask myself what operations are taking place inside of this argument. Well, I see a multiplication on top and I see a division in between that top and the bottom. You might want to consider putting the top all in parentheses or putting the bottom all in parentheses, and that won't matter when everything is plus, but it will matter if you have minus signs and you have multiple things on the bottom. In this case, it's not going to make any difference. Let's go back to the operation. In between the X and a Y, I had a multiplication, so I'll turn that into the addition of those two logs for X and Y. Then I had the X and Y on top that's shown by my beige parentheses here, and I have an N that's being divided, so I'll put a minus sign in front of the log N to show that that was a division. Last thing I want to concern myself with is that base of B. If I start out with a base of B, then I have to have a base of B in all the logs on the other side as well. Because when you do this, when you expand and contract, you can't change your bases. They must stay what they were. And lastly, I really had those parentheses there for demonstration purposes. They're not completely necessary in this problem. You have addition, it's not going to change that. And we're only subtracting one thing here, so we don't have to have parentheses in that. So there's my expanded log for the first example. Let's take a look at the expanded log for the second example. Again, we're going to start out by figuring out how many times we need to write that word log. If you look at what I have inside the argument here, I've got a 3, I've got an X, and I've got a Y. So we're taking the component pieces of that argument. And that tells me I need to write the word log 3 times. And again, in this example, I start out with a base of B, so I just have to make sure that I put a base of B on all my logs. Make sure it looks like a base. It's got to be a subscript, not something that's on the same level as log and not as big. Well, we've got 3 arguments. First of all, I've got a 3. And then I've got an X, and then I've got a Y. Okay, the easy parts. Let's take care of the multiplication in between the 3 and the radical. That means that that's going to become a plus in between those two logs. And then after I finish the 3 and the X on top, now I'm going to be dividing by the Y, so that's going to turn into a minus in front of that third log. The only other thing that I have to think about now is the fact that I had a radical and I had an exponent of 3. Well, you know from previous work that a radical is an exponent. As a matter of fact, a radical is a fractional exponent. So instead of thinking that as square root of x, think of it as x to the 1/2. If I come over here and write 1/2 right here, well, that's okay to start with, but I can't leave that exponent of 1/2 there. I'm going to end up taking all my exponents off of the expanded version. Exponents of 1/2 and I'm writing it big on purpose right now, the exponent of 1/2 is going to move down to the front of the log, and it's actually a coefficient there. So that is the same size. It's not small anymore like it would have been when we wrote it as an exponent. Down the bottom I had y to the third, so we can think that we had an exponent of 3 up here. Yes, I know I made it large on purpose. An exponent of 3, but in the expanded version we put exponents in front of the word log. It becomes a coefficient. And that's the final answer for this problem here. Remember that if you were to evaluate, if you had all numbers in here, then you could evaluate that yellow part and you'd be multiplying your result by 1/2. In this case, we'd be evaluating the yellow part and then we'd be multiplying that answer by 3. We're not doing any evaluations here. All we're doing is being asked to expand. Now let's go in the other direction. Now we want to write it as a single log or contract. Well, the fact that the instructions say a single log, and yes, it's still very important to read the instructions, means we're only going to write the word log once. You don't see a base here. And when you don't see a base in something, let's take a look at what our calculator will do if we don't see a base. I'm going to grab that log button that I have. Control log right next to the 1, and let me leave that base blank like you see on the paper, and let me just put a 7 in there for instance, and watch what the calculator will do. When you look at your input, it turned that invisible base into a 10. That means that when you don't see a base written, it's assumed by everyone that it's a 10. So you can either write them in if you want to, or you can leave them off if you want to. Whenever I don't see a base written, I'll assume it's a 10. And if it's supposed to be a 10, you'll be good to go on that. So a single log, the word log, base of 10. Now we're going to take a look at what arguments we have that we're going to have to put back together. I have an argument of an R, an argument of an S. So I'm going to be putting those back together in my single log. Place an R in here and an S in here. And now the last thing we want to take a look at is that 1/2. Well, in the expanded version you have coefficients, but in the contracted version they go on up as exponents. So I can write R to the 1/2 up here, but keep in mind that you're not allowed to have fractional exponents. So the fact that this was a fraction means I'm going to have to turn that all into a radical. So my final answer here would be log base 10. Whether you write the 10 or not is up to you. And I'm going to put an S in front of the square root of R. Whoops, I forgot my 3. I had a coefficient of 3 as well. So that coefficient of 3 has to become an exponent on the S term. And again, I'll show the parentheses with the argument. So that final blue log would be my final answer for this particular problem here. So check all 3 things. Take care of pluses, take care of minuses, and take care of any coefficients that you see. We had 2 coefficients we had to move up as exponents. And recall that you're not allowed to have fractional exponents in an answer. Moving on down to the second one here, a little bit more work going on. You have a couple of choices in how you do this. I will distribute the 3 first. It's a multiplier. That gives me 3 log base b of s plus 3/2 log base b of t minus log base b of r. So I just rewrote the problem by distributing that 3. Okay, now since we have the same base in all 3 logs and the instructions ask us to write as a single log, we'll write the word log once, we'll put a base of b on it, and now we'll get ready to set up our argument. Take care of every plus sign, every minus sign, and every coefficient. Let's start with the plus signs. There's a plus in between the s and the t. So I'll put those together as being multiplied. And then I have a minus r. The minus turns into a division sign in the argument, and we'll put the r down the bottom. Pluses and minus signs are taken care of. Let's take a peek at the coefficients here. I have a coefficient of 3 and I have a coefficient of 3/2. 3 is on the s, so I'm going to take that coefficient of 3 and move it up on the s as an exponent. The coefficient of 3/2 is being moved up as an exponent on the t, but let's take a look at that aside for a second. T to the 3/2. I can't write fractional exponents. I'm going to turn that into a radical. When I turn into a radical, it becomes the square root of t cubed, but the square root of t cubed can be simplified. And I'm going to split it up like this: square root of t squared, square root of t. That becomes a plain old t. So it looks like instead of having t to the 3/2 power here, I need to write it as t radical t. and that's all on top of the argument, just plain old r on the bottom of the argument. There's my final answer. Last 5 minutes of the video will be a couple of different example types from your homework, and then I'll put the answers to this homework sheet at the end of this video. Well, first of all, instructions are important. Write as a single log. That's part A. So let's write log base 3. We need one argument here. So we'll take our 27. That's a plus. We're going to turn that into a multiplier inside the single argument times 81. It's time to pick up our calculator. Do a 27 times 81, and that number becomes a 2187. So that turns into log base 3 of 2187. If you recall from your homework yesterday, that's just a number, and we can evaluate it by setting it equal to x, or by asking ourselves 3 to what power will give us 2187. I'm guessing that's 3 to the 8th power. I guess too high. Let's try 3 to the 7th power. Okay, so we know that this answer becomes a 7. And that's part B. I just evaluated that log and got the 7. You could have done that from the beginning. You could have evaluated this piece. That would have given you a 3, and evaluated this piece, and that would have given you a 4, and added those two numbers together, you would have gotten a 7 in the end. Part 2, we're going to first expand and then find the value. So I have, and I'm going to rewrite this here. Here's my argument. It's 3 times 243. So I'm going to put a log base 3 and a log base 3. I'm going to need one log for each of those two different numbers in the argument. We'll put the 3 in here. We'll put the 243 in here. Because we were multiplying inside this argument, we're now going to add those logs. And then last thing we have to think about is this 1/2 coefficient out front. Now when you think about it, I'm going to highlight the log piece of this, and it was 1/2 times that entire log piece. So now you can consider it as 1/2 times that entire log expression. And we'll come up with separate evaluations for each. It's going to be 1/2 times, oops, shouldn't use the highlighter to write with, 1/2 log base 3 of 3, this is going to turn into a 1. Log base 3 of 243 is going to turn into a 5. You're going to end up doing 1/2 of 6, which will give you an answer of 3. So here's the expanded version right here, and then the evaluation is a 3. You would have gotten the same thing if you had evaluated this single log in the beginning. Write each expression as a single logarithm. Be careful with this one. This one is a binomial. And we don't have rules for pluses or minuses inside of arguments, only multiplications and divisions inside of arguments. So that's going to be treated as a single argument there. Best we can do here is take that log base 2 and move the coefficient of 4 up as an exponent. And I suppose you could multiply it out 4 times. I'm not going to ask you to do that, but that's the only thing you could do, is turn this into a quartic equation or expression. Expand using properties of logs. Okay, we've got an x and a y, so we'll start with log base 4 of x and log base 4 of y. Since there's a division in between those two, we're going to put a minus sign in between the two logs. I did have an exponent of 6 up here, so that's coming down as a coefficient. I did have an exponent of 5 here, so that's coming down as a coefficient. In the final one here, we have to do a substitution. It's not hard. It actually works out very easy. Well, let's begin by expanding this log. We see division inside. We have a rule that says that'll turn into log base 2 of x minus log base 2 of y. And now we'll go back and pick up the rest of the instructions. It says that log base 2 of x is a, so we can replace this with a. And it says log base 2 of y is b, so we can replace this with b. My final answer is a minus b, and that's all there is to it.